Okay, we are going to discuss the property of elevation of boiling point when a non-volatile solute is dissolved in the solvent. We can take the example of water first of all. We can take the example of water. For example, we can take the example of water. Okay, normally water has the boiling point of 100 degree Celsius. Water has boiling point of 100 degree Celsius. When we dissolve some salt or some sugar in water, then the boiling point of water will definitely rise above 100 degrees Celsius. It will be certainly more than this. Suppose we dissolve salt in water. Okay, then the boiling point of water will be more than 100 degrees Celsius. It may be 101. We can take the example of 101 or 102. Depends upon how much salt we have dissolved in water. And I am telling you why it causes the rise in the boiling point. If I dissolve, first of all, I am telling you the definition of boiling point. What is boiling point? We are discussing the boiling point. What is boiling point? For understanding why when a non-volatile solute is dissolved in water, the boiling point increases. For this, first of all, we have to learn what exactly is boiling point and what causes the liquid to boil. Okay, let us take the example of water again. Example of water. Let this be water, and we are heating this from below. हीट कर रहे हैं इसको नीचे से. Then always upon the surface of liquid some pressure is exerted. Some pressure is exerted, and this pressure is called as the atmospheric pressure. This pressure is called as atmospheric pressure. Atmospheric pressure. And as we are heating the liquid, heating the water, then the pressure of the vapors from the water, it will start increasing. It will start increasing, and a juncture will come, a point will come when the vapor pressure of water becomes equal to that of atmospheric pressure. When the vapor pressure of the water becomes equal to atmospheric pressure. And it is at this juncture that the liquid starts boiling. इस समय क्या होता है? Liquid boil करना start करता है. Let us denote this by the vapor pressure. This is the vapor pressure. Vapor pressure. So at the boiling temperature or at the boiling point, what happens exactly is these two, they become equal. At the boiling point, the atmospheric pressure is equal to the vapor pressure of the liquid. Vapor pressure of liquid. Boiling point, the vapor pressure of liquid is equal to atmospheric pressure. Now let us take the example when we are dissolving some non-volatile solute in this. Suppose I am dissolving some salt in this. इसमें थोड़ा salt dissolve कर देते हैं. Then I am redrawing the diagram. Again I am drawing the figure. फिगर फिर से ड्रॉ करते हैं यहाँ पर, जस्ट इरेजिंग इट आउट। सपोज दिस इज इट, okay. Now in this case I have taken two things. There is salt in water. I have dissolved salt in water. Salt को water में dissolve कर दिया. Then if I have dissolved salt in water, again in this case also we have the atmospheric pressure exerting pressure on this, and since the salt is there in this, the pressure will arise from this liquid also. They will arise from liquid also. But since some surface of the liquid is occupied by the non-volatile solute, the vapors produced by the liquid in this case will be slightly less than in case of the pure liquid. The vapors produced by the solution in this case will be lesser than the pure water. And in this case, this is atmospheric pressure, this is atmospheric pressure, and the vapor pressure will be slightly less. ये vapor pressure है, तो vapor pressure in the case of solution, solution of salt in water will be less than in case of the atmospheric pressure at the boiling point, or we can say at 100 degrees Celsius. If you are taking example of water, then it is 100 degrees Celsius. When the temperature reaches 100 degrees Celsius, still the vapor pressure will be less than atmospheric pressure when we have dissolved salt in this. Now to make the liquid boil, liquid को boil करने के लिए we have to heat it further, so that the pressure of the liquid becomes equals to the atmospheric pressure. We have to heat it further. Okay, we will be heating it further. We heat the liquid further, due to which the temperature goes beyond 100 degrees Celsius. उससे क्या होता है कि टेम्परेचर हमारा 100 से ज़्यादा इंक्रीज हो जाता है, and therefore the temperature, the boiling may occur, boiling which occurs in the case of boiling point in the case of pure water and boiling point in the case of solution. This is solution and this is boiling point of water. In the case of water it is 100 degrees Celsius exactly, but when we dissolve some salt or sugar in water, then it will definitely be more than 100 degrees Celsius. It will be more than 100 degrees Celsius, because we have to heat it further to make the vapors equal to the atmospheric pressure. Now to calculate how much is the increase and what is the relation between the vapor pressure and the molecular mass, I am doing some telling you. Suppose the boiling point of pure water, boiling point of solvent we can say, or pure water, that is water, can be taken as T naught B. This is the boiling point of pure water, and boiling point of, suppose, the solution, which in this case we have taken water. In the water we have dissolved some salt, this solution. Let us take it as TB. This is the boiling point of solution, denoted by TB. and this is the boiling point of solvent denoted by T naught B. Then the increase in the boiling point will be increase in boiling point, elevation also we can say, elevation in boiling point will be denoted by delta TB, which will be equal to nothing but TB minus T naught B. TB will certainly be greater in this case. TB is always, in this case it is greater. T naught B. Okay, this is it. And for very dilute solutions, if the solution is very dilute, that is, we have dissolved very less of salt in water, then it is found that the increase in boiling point is proportional to the molality. It is proportional to the molality for very dilute solutions. For very dilute solutions, it is found that delta TB is proportional to the molality, small m, and we can replace it by a constant called as the KBM, where KB is called as the ebullioscopic constant, or we can call it as the molar elevation constant. Molar elevation constant, we call it as. And now if we just substitute m by the formula of molality, we will get the whole formula pertaining to this. पूरा formula आ जाएगा इसका. And we know that the molality is how much? Molality होता है, it is number of moles of solute, that is W2 by M2, solute denoted by 2 always, and upon the kilogram of solvent is always W1 divided by 1000. So if we simplify it, then it will be somewhat this, W2 into 1000 upon M2 W1, this is small m. And if we substitute this value of m in this formula, we will get the whole formula of delta TB. We have to substitute this m in this here, so we will get the structure of the whole formula delta TB, which comes out to be how much? Delta TB equals to KB and W2, KB into 1000 into W2, and below it is M2 W1. So this is the whole formula which relates the molecular mass of the solute with the increase in boiling point of the solvent when some non-volatile solute like salt or sugar is dissolved in water. And suppose we want to find the molar mass, we can reshuffle the formula. We can get the molar mass, we can just take it here, M2, and it will be KB into 1000 into W2 upon delta TB W1. So this is the formula for finding the molar mass of the non-volatile solute dissolved in the solvent. And here we can write that M2 is nothing but it is the molar mass of solute, non-volatile solute, and W2 is the mass of solute which is added to the solvent, and W1 is the mass of solvent, and delta TB is the elevation of boiling point, boiling point कितना increase हुआ, and Kb is called as the molar elevation constant. Kb is called as the molar elevation constant. This is it. And after that